Welcome to my horrible presentation on how to survey in Foxhole and my personal um, vendetta against our lack of maps in Foxhole. This is originally about classical and computer-assisted surveying techniques, and I forgot to update the date. Um, but surveying in Foxhole is basically just figuring out how to get things out of the game into a map form. So before we start, as I've mentioned, the session will be recorded, and please let me know if you do not wish to be recording, and I will stop the recording, and I can record the next one. All right, I'll just assume that you guys are all comfortable with recording. Because I've worked in the US defense industry and sat through many safety briefs, and this is going to be a 3-hour long presentation, I feel obligated to also do a safety brief here. Um, There is a potential for hearing damage due to excess volume, so please do check your volume and make sure that your headsets aren't set too loud. There is potential for long-term eye damage from staring at the screen for too long. Please sit at a proper distance from the screen and reset your eyes every so often by looking away from the screen. There is a potential for spinal issues from bad posture, so just sit up with good posture and avoid putting stress on your neck and lower back. I may use some vulgar language from time to time. Please enjoy yourselves with the vulgar language. We may have connection issues. Given that this is the EU event, I assume that none of you are quite close enough to Grid Square Foxtrot November, but if you do, please QSO Kilo Charlie 1 Whiskey Juliet Uniform QSW 7069 if you are licensed to operate amateur radio. Please be aware of any emergency exits in your immediate vicinity, and also if any ninjas that may appear at said emergency exits always have a secondary exit. And finally, avoid sudden movement, but also please avoid deep vein thrombosis. I do not want any of you dying on this presentation. So please hydrate, use the toilet, move, touch grass, etc. during an interval that we will be having approximately an hour in. All right, here's our agenda today. First, we'll start off with a brief motivation to why you should survey. We'll go over classical surveying techniques, which include binoculars and Foxhole Planner, all like in-game tools that you've probably heard of. Then I'll do a quick introduction to computer-assisted surveying. I'll do my pitch for my horrible thing called CaRTo. We'll have an interval of 15 minutes. Then we'll have a quite technical pipeline tutorial of about 1.5 hours. If that seems long, it's because it is. I'm sorry that the pipeline is very technical, and we'll stay on for some Q&A at the end. If you guys do want to not go over the pipeline tutorial, I can also skip. You can also drop out during the interval, and I would not be offended because it is again very technical. Um, but yeah, any questions on the agenda? Cool. So here are my qualifications. All right, moving on. Okay, here are my actual qualifications. My actual qualifications are that I have a BS in electrical and computer engineering, which technically means I'm qualified to do this, or like I have like academic experience in doing this from the computer engineering side. But personally, I more focused on the analog electronics and systems electronics side. So this really wasn't my specialty. I've also spent 8 years in the open source, what's called the geoinformatics and cartography community, which is basically just like GIS and making maps. In particular, I've had some involvement with a company called MapLarry, who is now under Facebook Meta. Welcome. Whoever just joined Life Invader, welcome. Yeah, I've been involved with MapLarry for most of that time, and they are a major contributor to OpenDroneMap, which is a software that is um, in this like sort of software stack, and they also basically wrote OpenSFM, which is part of OpenDroneMap, or use an OpenDroneMap. Um, so yeah. This also means that Facebook owns like about 2 petabytes of my data, like in addition to what they've been collecting, but that's a different discussion. Um, so before we start, let me draw a brief distinction between surveying and cartography. So surveying is more of a science and cartography is more of an art. So surveying is more about what is the geometry and cartography is how do you communicate like what the geography is. Um, if you want to put it in terms of a 3D model, a survey is more of like the mesh itself, like the untextured mesh, and the cartography is the texture that you put on top of it. Um, we'll be focusing more on the surveying side, but the cartography also comes quite naturally from like it's you get the data from surveying and then you put that into cartography. So let me open up to the floor and ask, why would you want to survey something, and why would you want to survey something in Foxhole specifically? Fair, that is completely valid. How would you use it in the partisan context? Yep. hmm Yep. Like documenting a facility. Yep. All right, you guys basically touched on like most of what I've said. Unfortunately, maps are cool as shit is not one of the reasons I listed on here, but I'll definitely add it later. Um, so yeah, 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 totally. So you guys touched on most of these actually. So um, providing diagrams to explain how a facility works. I think Danny said that that was something that would be helpful. Um, or I think so, right? Um, documenting an enemy facility for partisaning to identify weak points and targets. Recording, I said a bunker defense for this, but it could really be any facility, so that it can be either replicated from the future or that we can learn from it in the future. The one that you guys didn't touch on was in like when you're doing T1 to T2 planning, it's kind of important to figure out where all the trees are. Otherwise, you're just sort of like trying to fit in the design around the trees that are already existing. It would be really helpful if you knew where all the trees were beforehand before building. And obviously, there are maps cool, sort of many more reasons that you would want to survey. That's what I'm Yeah, that's what I'm hoping to do. Sorry, let me just change my OBS. I think I'm not getting Discord audio on here. So, uh, it it does slightly. Sorry, let me get all of your wonderful voices in here. Uh, all right. Can you guys just test really quickly, just so that I can see if? Oh, yep. Okay. Sorry.
Check,
So,
check, check, check.
yep. Cool. All right. Um. So So the question was, could you do this for like Intel purposes? And that's what I'm hoping to do. It is probably like third priority on my list, but with like you can reduce the quality enough. Like I could probably get most of these turned around in 24 hours if I like don't sleep. But yeah. Um,
That's probably not viable for an entire war.
yeah, it's probably not viable for an entire war, but like also like as you'll see, like a lot of this is just like the computer is processing a lot of this. So I can like leave the computer running and then just do the post processing manually later. So, but I'm hoping, I haven't tested it on like a partisan target yet. I'm hoping that will work, to answer your question. Hey, Mayo. All right.
Hello.
Hello. So, as a someone of Chinese descent, I'm obligated to give you a Chinese quote to help motivate our discussion. Instead of doing the normal "know your enemy and know thyself," I chose one from Zhuge Liang, which is from my parents' hometown. So this translates to an army's discipline is number 15. First is apprehension, elucidating the opponent's secrets, and 15th is assessment, understanding oneself and the other. So um, I just wanted to include this quote to like underscore the importance of just knowing your own capabilities and knowing your opponent's capabilities is like quite important in military strategy. Like historically, this was written in ye old days. And the fact that there's like a lot of other ones like courage and stuff, but the fact that these were put in like the two most prominent places, the places that you would remember first and 15th, just underscores like just how important just intelligence and knowledge is for um for this sort of thing. Surveying could be obviously a great part of that. So we'll be going over classical and computer-assisted surveying again today. This is just sort of a compare and contrast between classical and computer-assisted surveying. Classical surveying is probably the ones that you're more familiar with. It uses more accessible tools like binos, Foxhole Planner, and the map mod to sort of get a more accurate image of a place or like a more detailed image of a place than what you get just from the map itself. However, it being basically manual, it's very labor intensive, but also because it's manual, you get potentially a faster turnaround. Unfortunately, the in-game tools are also pretty imprecise, and you also like need to be on site pretty well, so it's not necessarily suitable for partisaning. Computer-assisted survey, instead of using binos and Foxhole Planner, things that we all have in game, or out of game, hopefully. It uses much more technical tools. This is like the software that I use in the pipeline. It is semi-automated, so it's less boots on the ground, but it does have a slower turnaround just because there's so much number crunching that is involved, but you can kind of throw processing power at it to make it go faster. One of the good things is that it's pretty cool, it's pretty precise, it's pretty, and instead of requiring you to have boots on the ground for like an hour at a time, you can just record a video, and that makes it more useful for like, let's say, partisaning. Anyone have any questions about the differences between classical and computer-assisted surveying? Cool. So without anything else, let's go into classical surveying. The workflow for it is pretty simple. First, you want to grab your surveying tools, which is usually a bino, but you can also use some other things in game. You want to make your measurements, distance in ASCII, and then you document it in Foxhole Planner. The theory is somewhat like this. In case you haven't seen this, this is from the missile knows where it is because it knows where it isn't. This is also actually how real missiles kind of work. But basically, in order to know, a more formal way to say it is, in order to survey something, you need to know where you are from a known position, and you need to know where you're looking at, like the distance in azimuth. Um, and then you can calculate your position, you can calculate the thing you want to measure's position relative to your position. So this raises two questions. One, how do I find a known position, or how do I know my position? And second, how do I determine my distance and bearing to another point? The first one is, these are two relatively simple questions to answer. For the first one, there is a tool in the game app that are grid coordinates. So if you haven't seen this in game, it looks kind of like this when you mouse over an area and region. You'll see this like keypad of numbers, and what you want to do is align yourself with the intersection of a grid or one of these numbers at the grid key. Um, and and then this can be translated into Foxhole Planner by turning on the grid. So let me show you that in game. So right now I'm standing in home region, and you can see that right here there is this grid key thing that pops up. So if I run over to the other side of this bridge, I will stand at the intersection of a grid key, roughly right here. And then from here, what I can do is I can use the command chords to determine what grid square I'm actually in. So if I type in chat exclamation mark CORDS, it will tell me that I'm in coordinate J8K5, which is this top one here. If I move more to the west, it should tell me that I am in J8K4. So if you just wiggle yourself around slightly and you see yourself being in like all four squares, you know you're pretty close to the intersection. The other way you can do this is obviously just visually aligning yourself with the grid square. Seems like it's actually on top of the bridge, so I'm not in the best place to do that. But yeah. The other thing is that improved map mod actually helps a lot. So if we go back to my map here, you can see that I can zoom in pretty deep with improved map mod because it has a higher resolution. Whereas if I go to my other account that does not have improved map mod installed, you can see that I can only zoom in like about half as much. So in addition to just being a nice visual QOL, improved map mod actually does help you align yourself on grid coordinates. Does that make sense?
Yep, makes sense.
Cool. So I should also probably show you guys how to turn on grids in Foxhole Planner. So in case you didn't know, if you go into the map section over here, you can, after you turn on the display, right now this is Viper Pit, you can also turn on grid, and that will show you the grid, and it will also show the key squares also. So this is how you translate it into Foxhole Planner. You can also turn on improved map mod over here if you want to base it off of like improved map mod. All right. So that solves the known position problem. The next one is, how do you know the distance we're bearing? And this is also relatively straightforward. You need to find something that tells you it, basically. So the most obvious choice is binoculars, but you can also choose like a ship spotter seat from like a freighter or a large ship. Observation bunkers also have this ability to show you distance and azimuth, and mortar houses also do this. So you can see this here. This sort of thing I can also show you in game, where if I equip my binos and I look over here and I look over here, you can see that it shows me my distance and azimuth of 17 meters and 96 degrees from north. I trust you guys are all mostly familiar with that. So now how you would put this into Foxhole Planner is, let's see, I go into my survey lines layer, is you would click this binoculars tool down here, and you can just click and drag to make a, or you can, oh, I locked us, that's why. You can click and drag to create a binoculars line, and then you just, let's say I was on this grid square, you just want to match the distance in azimuth to here, or you can change these two numbers. So 16 distance and I think 96 azimuth was what we were looking at earlier. Hey, Fenty. So this is basically how you would put it in Foxhole Planner. You can see over here that this is the survey lines that I did for, these are the survey lines I did for hard caps when I did it the first as-built around. You can see that there are a lot of them, and that's because I needed to do this for every single, sorry, Fenty, you're getting a lot of like external noise. All right, sorry, I'm just gotta turn down Fenty. You can see that there's a lot of survey lines because every single feature needed a survey line using classical surveying. And you can all see that they're emanating from a grid intersection. Another thing you can see in here is that sometimes I surveyed things from two different points, like right here, and you can see that there's a bit of error, so it's not quite pointing towards the same point. That brings us over to sources of error. There's about 2 to 4 meters of unavoidable error when you're using like binoculars to survey or any of the other classical surveying techniques. And what I found is that there is roughly 3 different sources of error. So the first is how well you position yourself on the grid, or how well you know your known position in the case of like a static thing like a mortar house or a observation bunker. What I found is that the intersection is easier to position on than the grid keys, like the center of the grid, the numbers on the center of the grids, just because you have sort of like a crosshair to position yourself rather than just a single point. There's also quantization error, which is if you look at like what the numbers are giving you, it only goes up to the nearest meter and degree. So that on average will add about like a quarter to a half of meter of error. And then the other problem is having non-zero player size. So from what I've been able to tell, the binoculars measure from the binoculars and not like the center of the player. So if you start rotating around, it will also add like half a meter from just the binoculars being held in front of your face. So overall, most of this comes from like bad positioning, basically. But you get about 2 to 4 meters of unavoidable error. And some tips for when you're doing a classical survey is that 2 points are enough to fully define a structure's location and orientation. So if we go back to my horrible little thing here, you can see that for this foundation, I just have 2 survey lines going from one corner and the opposite corner over here. And that was enough to define its location and orientation relative to everything else, as long as you know what's inside of it. Um, the other thing is you need to be at the same height as the thing that you're surveying, otherwise it'll factor into height into what you're surveying. So if I go back to this bridge and I try to like bino something that is right in front of me but is like below me in the water, you can see that will say like it's a distance of like 6 meters extra because it is also measuring the height even though it's like on the map it's right in front of me. So just be aware of that. You want to be on the same level. This also applies to like slight inclines that you might not be able to tell. So this says 21 meters, but it's probably closer than that on the map because the ramps on the bridge. Um, for like really important points, you want to survey from multiple control points. This will just sort of help average out the error and make sure that you're not you're not having like a single source of error. So um, you can't always survey from multiple points. Um, also try to like be as close as you can to your survey to the point that you want to survey. If you try to survey from too far, it will increase error from the angle increasing. So like a, the same angle will have the same angle will be like a bigger distance if you're surveying from a bigger distance. I don't know if that makes sense or not. Um, Also, use the compass tool or the binoculars tool for survey lines. You can technically do this with like the normal line tool by um, by turning on distance and azimuth here, which I did here because I was a noob and I didn't know what to do. But the binoculars line also allows you to input in the actual like distance and azimuth, which is a lot more useful. Um, This is just something that I like to do, but it's helpful if you put your survey lines on a different layer than your buildings and obstacles and like no build areas. Um, so like the layers tool here, just in case you want to like come back to your survey lines instead of having to delete it every single time, you can just lock it and just hide it, which is really helpful when you're working on a big project. Same thing goes for like obstacles. So like trees here, I can just hide it. I guess I didn't put the trees on a different thing, but like the rocks I did. All right, that wraps it up for classical surveying. Does anyone have any questions on it? Cool. So with that, I'll move on to computer-assisted surveying. Um, I should put a disclaimer in here first that I was not the first person to develop this. There have been many people before me who developed this, but I think I've made it faster. The overview for this, or like conceptually, it's kind of simple. There's really 4 steps. So first you want to take images from in-game and then stitch all of the images into a 3D model, which modern software can do. And then you take the 3D model and then you get an orthonormal view, which is the sort of bird's eye straight down perspective that you see in say like Google Maps before you start zooming in. And then you can import the orthonormal view into Planner and then digitize off of that, or you can just use the orthonormal view itself as as its own sort of like diagram. The problem with this is mainly step 2, stitching the images into a 3D model. It is very computationally expensive to do this, and so this, when you actually start doing it, it explodes into like it ex you'll see on the next slide. This thing, step 2 is this like whole like this whole like 6-step ordeal that takes up actually most of the time inside of this pipeline. This is an overview of this
Oh,
process. Yeah,
my bad. Just,
hey, Captain.
I think I was
Um,
supposed to.
yeah.
Uh, yes. Go ahead, I'll mute myself.
All right. And so just to go over this first, instead of taking individual images, what we can do is we can take a video in game and then we can chop the video up into individual frames. So that's what these two first steps are doing. Where's my mouse? That's what these two first steps are doing. And then we take that and run it through the meat of the pipeline, which is making 3D model fragments, stitching your fragments together, cleaning up the whole model because sometimes there are a few issues with it. Bring it into Blender to make the ortho image, so turning the 3D model into a 2D image, making it look pretty, and then importing it into Foxhole Planner um, and digitizing it using like actual facility buildings and whatnot. A lot of this is pretty manual, which is the purple and yellow. The red parts take almost no time, basically, relative to the other things. Um, the green potentially can be automated. I just haven't gotten around to automating it yet. And the blue is the true meat of it. This is where the computer tries to crunch the numbers and massage everything into a 3D model from 2D images. That is the thing that you can throw compute power at and make it go faster. In computer science, we would call this MDALLable from Amdahl's law, which is basically you can throw compute power at it and it will go faster. The purple things are non-MDALLable because you need a human in the loop and it's you can't really get that much faster at it except for skill. Does anyone have any questions on this pipeline? I know there's a lot in here, and I'm sorry, it's just going to get worse.
Have you tried capturing like a complete hex in Foxhole? Have you actually tried to do that and apply this process?
No, I feel like that would take days to do.
Right.
Yeah.
That was
You'll
my
see a
next
time.
question. How long
Yeah.
does it take to run like this complete pipeline?
It takes about 30 minutes per like full grid square, if that makes sense.
Gotcha. Okay.
At
Full
the
grid
very
square is
least.
in the 9 by 9.
Yeah, yeah.
Sorry, the 3 by 3.
Yeah, the 3 by 3.
Gotcha.
Yeah. So I think there is like something like 300 of those in a hex.
Jesus. Okay.
So yeah, it would probably take like a full week to run it, and then by that point it's out of date.
Yeah.
Yeah.
Okay.
It might
Still
be
interesting.
useful just for mapping geography, though.
Yes, but at that point I would rather just get the game files, and digitize those.
Oh yeah, I forgot that's
So
that's a thing.
yeah. I forgot to mention that these are also parallelizable. So basically, you can split one task up into many smaller tasks when you're processing what I call 3D model fragments or different parts of the 3D model. And you can have multiple people or machines work on this and then merge at the fragment stitch step. So here are some outputs that I've done. So this is the hard cap screw port that I was showing you earlier after we did the rebuild. And this is something that someone else did. This is Astrosius from Legio in War 119. Legio's basin for McConnell and I think Reaching Trail. I should also thank Astrosius for helping like consult on this whole thing. But you can see that it's not like perfect. There are holes in here where I didn't capture things. There are some color grading issues where I started like at like 6 a.m. in game and I ended at like 8 p.m. in game. So like this part is like a different color from like all of the other parts. You can see that there's a bit of a there's like some artifacts from it not stitching properly, and this is because this part started shrinking, and then this part I captured in a line, so you can see that it's like duplicated in a weird way over here. So it's not perfect, but it's pretty good. So going off of that, here are some things that the 3D construction process really struggles with. There are a lot of these, but you can mitigate some of these. The first is a large empty area. There isn't really anything that it can latch onto and sort of match when it's looking for different features to like stitch together the image. But you can place things in the world, in the game world, like storage blocks blueprints or like motorcycles or dinghies in water to give the image processing something to latch onto and to actually stitch things together with. Trees are also something, unfortunately, that it really struggles with. This is also like something that this sort of thing struggles in real life. If you've ever seen like the Google Maps 3D view and how it's like all blobby and like not really tree-like. Trees are just too visually busy. Foxhole also does this annoying thing where if you're under a tree, it'll like cut away from it. So like if I run towards this tree over here, you can see that it's if I use binos, it's fine, but if I run under it, you can see that it cuts away the canopy and it just shows the trunk. This really confuses the reconstruction. But again, you can use binos or like obs bunkers to mitigate that. Even though that's like a problem, you can still run towards the tree and get a good idea of where the tree is because it will usually reconstruct the blob or at least the trunk. Cranes are also a problem because they're just too high and close to the camera, and there's like a bunch of fine details on the boom that's really hard to reconstruct. And also, when a crane boom intersects with something, it goes transparent, and 3D reconstruction really has a problem with like transparent things. So it's just like a triple whammy of just like of bad positioning, fine detail, and transparency. The insides of buildings are also hard. I can't really show this because we're in resistance phase, but if you run into a building, it will cut away the roof, and you can mitigate this to a certain extent by pressing Control, which will show the roofs. But there isn't really a reason to, or not really. There are some like niche cases where you do want to capture it inside of a building, but it's usually just easier to just not enter a building when you're recording source footage. Transparent gates are again a problem because it's transparent. You can see, actually I don't have it up right now, but the transparent gates will sort of try to like copy the texture of a thing behind it or it just won't reconstruct at all because it's transparent and it can't really see it. Overhangs is also a problem just because you're in a top-down perspective, so it won't be able to reconstruct inside, like under the overhang. Players and moving vehicles are also a problem because the players are moving, the vehicles are moving, it's trying to reconstruct, it's assuming things are static. So if you're just running around and not using binos, like this, you'll see like a trail of player artifacts sometimes. You'll also sometimes see the vehicles get incorporated into it. A higher sampling frequency generally reduces player artifacts, but the easier way to deal with this is just to use binos. And then the last thing are just things that are just way too thin to reconstruct. So these are power poles, power lines, barbed wires, T1 fences, and gates and signs. It's just too thin. It doesn't give enough thickness for the 3D model to like actually give something to. All right. So this is where I do like my tiny pitch on CaRto. So CaRto is my Quixotan crusade to make maps of everything in MBG. So what if we could have like good maps for all of our facilities like it did for hard caps? What if we could like map out AI coverage of an enemy hardpoint and not just say there is a bunker here? What if we could actually say like, hey, like these two MG garrisons have a really bad overlap in this area, so we could rush that. Or what if we could plan around trees and obstacles before T2 and Foxhole Planner and not have to go day of T2 upgrade and be like, oh, there are trees here, we have to shift everything over. What I'm planning to do with CaRto is turn these what ifs into why nots. So why not have a map that can do all these things? Does anyone have any questions on the classical surveying as we've laid it out, or on what I'm trying to do with CaRto? All right. If not, we're going to go to our interval. So quick break. All right, hopefully everyone is back. If you haven't already reacted to the chat message with how technical you are according to the slide, please do that now. All right. All right, I see most of you are at like a 4 or above, which is good. Because unfortunately, a lot of this is going to be at least a 3 to the one person who reacted with a 2. I'm sorry. This is all going to be rather technical. Yeah. Basically, assume that everything is a 3. Some of these is going to be higher than the 3 that I'm going to be marking in the slide title, or with portion markings. And this is also, again, technical, so just feel free to unmute and ask any clarifying questions that you may have as we go along. And again, this will be rather long also, but without further ado, let's go into a pipeline tutorial. Again, there's going to be a lot of info on these slides. I think one of these slides has like, one of these slides has about like 800 words on it. So it's going to look like this Afghanistan Stability Coin Dynamics slides. I'm going to be skimming through this live, but this is more intended to be like a detailed guide that you can follow along with later if you want to implement it on your own. But yeah. If anybody has any problems with reading the slides, which will be a problem, I'll turn on Zoom also. So just feel free to pipe up, basically, is what I'm trying to say. All right. Cool. So just a brief introduction to like the software that we're going to be using for this pipeline. There is a lot. This is in no means like something that is like streamlined yet, and I frankly don't think it will ever be streamlined. Otherwise, you'll have like a 200 gigabyte sort of download. The first thing that we start off with is a screen recording software. I like to use ShareX. You can also use OBS for this. It's just used to capture in-game footage. Then we use FFmpeg, which is a command line sort of program to extract or like sort of split out still frames from the video. The meat of this process is something called Open Drone Map, and specifically its web interface called WebODM. WebODM generates 3D models from primarily aerial imagery, and it's obviously good because the top-down perspective inside of Foxhole looks a lot like drone imagery. We then put it into MeshLab and Cloud Compare, which are two actually very comparable sort of programs. I just like them for different reasons that we'll get into later, but they're both manipulators for 3D meshes. They just help you edit 3D meshes a lot easier. Then it goes into Blender, which is, you probably know it as a 3D animation software. We're going to use it to render a static image, the ortho image. And then optionally, you can also use GIMP, or if you're more familiar with like Lightroom or Photoshop, to just sort of edit the photo and make it look good. Blender, unfortunately, is like probably like the second simplest part of this whole process, which if you know anything about Blender, is saying something about this whole pipeline. So again, I apologize for how complex this pipeline is. Anyone, just before I go on, has anyone like downloaded the software yet, or like have any familiarity with the software?
I've played around in Blender before, but other than that,
Yeah.
Just FFmpeg.
Yeah. The things that we are doing in Blender is also pretty easy, relatively speaking. Like there's no like weird animation or like stuff like that. So, yeah. Here are some download links for if you do want to eventually download the software, and installation guides if they have any. So you'll notice that some software that, if you're familiar with the space, isn't used. If you browse the Foxhole Reddit, you'll notice someone. Let me actually find it. That someone, like, I think 2 days ago, posted another 3D mesh, and they used reality capture. And Kaloom for that looks like this. If you guys browse Foxhole Reddit, they use reality capture for this. That's produced by Epic Games. The problem with reality capture is that what we call image registration, or basically like stitching together images, is not very robust. It's very fast, but it expects like a very high density of images to actually stitch anything together. So like you'll get a lot of like weird stitching artifacts. And with the density that you usually get from Foxhole, you need to manually register them, or like manually give the program points to align them. Kaloom, I think, spent like 8 hours just like finding points within different places. So the other problem is that it's proprietary software, and all of these pieces of software are free and open source, which is great because you don't have to pay for any of it. Reality capture is free for hobbyists, but it's not open source. It's made by Epic Games. So yeah. The other thing you might be using with thinking of is Hugon, which is another open source thing, but it's a panorama stitcher, but it only works with 2D flat scans or single point panoramas, and we don't really have those in this pipeline right now. Is there any other software that you guys know of in the space that you would think people might use?
What's the NVIDIA capture thing?
Shadowplay?
Yeah. Is that what you meant, or does that not affect it? It's just the
I think that's what it's called, right?
I actually have never heard of that
Yeah.
before.
It's just a way to capture video.
Yeah, I
Mhm.
guess you
via
could
NVIDIA.
technically use that too. It's just it would feed into FFmpeg if it's just capturing video.
Okay. So
Yeah.
that doesn't matter. You're
Yeah.
Yeah,
worried
you
about
can
that.
you
Okay.
can also use that too. Yeah,
Okay. Cool.
yeah. I think metal should also work. Like this part is very agnostic. As long as you can get like sort of a video file, you can shove it into FFmpeg and it will spit out
Gotcha.
a bunch of images for you. All right. For reference, here are my computer specs. It's a medium spec laptop. Yes, I ran this on a laptop. An Ultrabook, in fact, that doesn't have any cooling on it. I also ran 4 Foxhole accounts at the same time on this laptop. So basically, what I'm trying to say is, if you can run it, if I can run it, you probably can too. Especially if you have like an actual dedicated gaming rig. Yeah, you can compare your CPU and GPU and stuff like that. The main limiting factor for this is RAM. So like even though like I have like a relatively like mid-powered like CPU and GPU for like a gaming rig, the 16 gigabytes of RAM is a problem. I would probably need 64 to actually for it to actually become a problem. You can also see that my computer was very unhappy during this process. It overclocked itself by 1.6 gigahertz. The CPU ran over 100 Celsius, which is what I think the CPU's like thermometer can actually measure up to. So it's like over that, which is not good. The CPU load was 100%, and there was 78.2 watts of power going to a CPU, which is not good. Use a GPU is what I'm trying to say. Here are the minimum computer specs. You can technically process off of this, but it might be a bit slower. Again, the limiting thing is RAM, really. If you have 16 gigabytes of RAM, you can probably run this. Yeah, like ideal computer specs look like this. Obviously there are many things that you want, but like you probably want at least 32 gigabytes of RAM. That's probably the most important thing. And just having 256 gigabytes of free disk space is always helpful. But again, RAM is mostly the limiting factor here. I know we touched on this before in terms of a time estimate. It's roughly like an hour and a half per minute of video, and a minute of video is roughly 1 grid square. So a 10-minute video will take about 13 hours to fully process. With about 1 hour of pre-processing time and 2 hours of post-processing, so you're only like really like actively working on it for like about 3 hours of those 13 hours. The other 10 hours just waiting for the computer to crunch, and this will obviously vary with your PC specs, but mostly with the fragment reconstruction part of it. Again, here's the workflow in a list form. We'll be going over each step of this. I will be skipping over some parts, especially within step 3, which has like 7 slides to it because it is the most technical part of it. But without further ado, let's jump into it. So, oh, also I forgot to warn you guys again, but there are going to be a bunch of walls of text in this, so again, I apologize in advance for the death by PowerPoint. Step 1 is to get the source material or record a video. A lot of these are just recommendations. You can get good video from basically any sort of video, but ideally you want to follow these recommendations. These also sort of apply to like real reconstruction if you're doing it with like a drone or with your camera. You want to record during the day. This is kind of obvious. The lighting changes during night are not really great. You want to use a spotter seat or binoculars instead of just running around on foot. This eliminates like the tree and building cutaway errors that I was talking about before. It allows, if you're partisan surveying, you can survey from a distance. You can also be on foot, just ideally don't be in a vehicle. Or if you are in a vehicle, try to avoid the vehicle itself, or try not to move the vehicle. You want to play in as high resolution as you can, and obviously record in that high resolution to get a more detailed reconstruction. You can also record in high resolution and then have OpenDroneMap down sample the resolution to make it go faster, but it's always good to just have more resolution. You can turn off shadows in the game to avoid like time of day issues so that like the shadows don't affect it. I find that to be helpful. Press F8 to hide the UI. You do need to press F8 twice in order to also hide player names. If you just press it once, like you'll still see like the player names floating above people's heads. You can keep those in, I guess, but it's easier to. It looks prettier if there aren't like random player names floating around everywhere. You want to rotate your view basically constantly to capture things from all angles. This is really hard to achieve in practice. But basically you want to like continuously rotate and try to move based off of that and not move your camera view and then rotate and then shift it again. That leads to some kind of weird errors from the fragmentation process. You want to pay attention. You want to give special attention if you're trying to like photograph like cranes or trees. If you don't give enough things to reconstruct it from, what you might get is like a crane boom just like sort of pasted onto the ground instead of being where it should be in the air. Again, try not to enter buildings or trenches because the building or bunker internal view messes with reconstructions. There is a problem with edge effects where basically the edges will start curling inwards or upwards. So you just want to have like a sort of safe margin around it so that you don't have to cut that off when you're doing the reconstruction. And finally, you want to record in patches and blocks and not in like long straight lines. So what do I mean by that? You should like try to record in like one patch at a time, like this, where you're sort of like the line is sort of like staying in the same sort of area rather than like going like this. This is technically called a boost for fade on path, which is like as the cow plows. So like when you start splitting this up into like smaller segments, like all of these will be like one line, another line, another line, another line, and you can get like this really nasty artifact called bowling from that, which is where the whole 3D reconstruction like curves in a weird way that doesn't actually exist. If you start chopping these up, this will be like chopped up in like one patch, another patch, another patch, and that having it like take up a 2D space instead of a 1D space sort of mitigates the bowling artifacts to a great extent. Technically, we would call this like time locality being also like space locality. This is not very space local. This is very like 2 points close in time will also be close in space here. 2 points close in time here may be like separated by like your a whole like width here. This is actually not a problem if you're planning to run everything in one whole batch and not fragment it. I'll explain what I mean by fragmenting further on. I know I've used it a lot here, but the problem is that for a large data set, it's very slow to process everything at once versus cutting everything up into smaller chunks. and then processing those smaller chunks and merging those together. Does anyone have any questions about recording? Cool. The next step is using FFmpeg to extract all the still frames from the video. Basically, you just want to move the video file to your folder and then just run this command. I explained what this command does in the bottom, but what you'll get is will look something like this. So we'll get a folder that has a bunch of extracted video frames out of it. You can see for hard caps, I recorded about 27 minutes of video and I got 1,600 frames, which is a lot, because it is a lot. Does anyone have any questions about this? Okay, cool. The next part is definitely the worst part of this. It's batching the 3D model fragments in OpenDroneMap. This is the most involved. You'll see that there is 7 other slides in here that is talking about the technicalities of this. This also takes the longest time, but it's also mostly waiting for it to process. Fenty, I actually don't have an example of the bad type of recording. So I unfortunately can't really show a good type of recording. But basically the thing that is intuitive to do, which is recording in a neat path, is not the best thing to do. You're actually better off just recording in a random in a sort of random block sort of thing, where you're just sort of going all over the place and rotating your camera constantly, rather than doing one pass all the way north, one pass all the way west, one pass all the way one pass looking north, one pass looking west, one pass looking east, one pass looking south, sort of thing. It's just yeah. I can show you what the results are for it later, but the difference between what sort of things you get from a random block versus a straight line later. But yeah. So batching 3D model fragments. So basically what we're going to be doing is we're going to be processing them in little chunks. So instead of processing all, in my case, 1,600 images at once, we're going to be processing 100 at a time. This makes it go a lot faster. After you download OpenDroneMap, what you want to do is you want to use git bash, which is a command line interface, and you want to run webodm.sh start and that will start the ODM process. You can also use GPU acceleration for Linux systems. We'll get into that later if you guys feel technically up to it. Do you guys want to hear about that or no? I will take that as a no because it's very technical. Then what you want to do is navigate to localhost colon 800, and you'll get a interface that looks something like this. And then what you do after adding a new project is you can click on select images in GCP and go to your frames folder and select some frames. I usually like to do 100, as I said before. So let's do that. So these are the first 100 frames. You can do fewer images for faster processing, but you'll have to do more reconstruction afterward. It'll also be less usable space. You can also do less overlap for faster stitching, but for faster stitching, like in post-processing, but there might be like worse results from like stitching errors. Batch size also is hard limited by RAM. There is a table inside the OpenDroneMap docs for how much RAM you need for a given set of images. I like to do 100. It seems to work well for about 16 gigabytes of RAM. It takes about an hour on a CPU. It takes about 30 minutes on a GPU, on my GPU at least. What you want to do is you want to turn off resize images and go to the options and uncheck uncheck or check off skip report and skip orthophoto. We will not be using those. And then click review. It will look something like this. What you can do instead also is you can do high resolution if you want a high resolution 3D model. But for this, these are usually fine. And then click start processing, and it will upload those to your computer and start processing it. Yeah, like this. I'm going to cancel this so it doesn't keep running my computer and hogging all of the CPU. But what you'll see when it's done is this progress bar will go very slowly towards completed, and it will complete later. You can close your web browser while it's processing. It will process within the it will process like in the background as long as you don't close the skip bash terminal or Docker desktop. And once you're done, you can stop all of your ODM containers by issuing this command that will end it gracefully. You can also just kill Docker, but that's not so graceful. Does anyone have any questions about this? And how much detail do you guys want me to go into about this? Because I can go very detailed.
I think it's fine like this.
Okay.
I can read it later if I need the commands, etc.
Yeah. One thing I will say, if you have a GPU, you should probably run it on your GPU, but it requires Linux. How you do that is through this slide. Basically shows you how to do it. It's very complex. I will not be going over it here. This for me sped things up by about like 6 times, so it's worth it. There's also more information here about why we're batching, why we can't use. There's a functionality called split merge. Why we can't use that. Why we can't use orthophoto from ODM, which would be really nice. What it's doing. There's also this horrible flowchart and OpenDroneMap. And how you can also, if you have multiple computers that you're not using, you can like run ODM on them and control them from one computer. Again, please be careful with this. This is a great, if you do this wrong, you can open up your computers to a bunch of malware. Please be careful with this part of it, but yeah, you can review these slides after. You can review these slides afterwards. Can you guys still hear me? All right, sorry, I think my thing's disconnected. Can you guys hear me now?
Yeah.
Okay.
Yeah.
Yeah, okay. I think my headset just disconnected. But yeah, there's a lot more detail on how you can do open drone map and optimize it and all that. Once you're done with that, we can grade the fragments. So grading the fragments just means like going through them to see what's good and what's bad. So in an open drone map or a WebODM, you can open this up by like open up a task by looking at view 3D model here. You'll see that's in a point cloud form right now. If you turn on texture model, it will actually like properly turn it into a texture model. And you can see that this area is actually pretty good. It reconstructed pretty well. You can see that like there isn't anything majorly wrong except for near the edges, which we expect. All of the cranes have your crane booms properly aligned. You can see, although this one doesn't really, you can see some crane artifacts on the ground here. So you might want to cut these out. You might not want to, depending on how much fidelity you want or like how good you want it to be. You can also see crane boom over here. But overall, this is pretty good. You can see that it's like relatively flat where it should be. This is an example of a good fragment. There are 3 ways that it could look bad. The first one is a misstitch, which is features that features have been put together that shouldn't be next to each other. So I think this one was kind of bad. You can see here that it's sort of randomly inserted in this rail line where this rail line shouldn't be. Like this rail line just does not exist here, and it's as a result it shoved everything up. It shoved like these parts up. There really is no saving something like this because you don't know like the quality of the rest of the reconstruction. The other sort of major defect is something called disjointedness, which is sort of a similar idea, but it's where like you have two or more parts of the reconstruction, but one of them is like oriented in a at an angle relative to everything else. Usually disjointedness results from having not enough features for the reconstruction to latch onto. So this is an example of a disjointed reconstruction where you can see like this part is relatively good, and then this part where there's like nothing, it's just like all ice, just got oriented like at 90 degrees relative to everything else. Again, you can kind of cut this off and not use it, but you also don't know the quality of like the rest of the reconstruction, so it's generally better to just throw it out. The other problem that is pretty common, and this is usually down to like what I was talking about earlier about like surveying in a line versus surveying in patches, is bowling. So if I pull up this one, you can see that I sort of like ran around the edge of the facility, and that's sort of a line. But if you look at it from the side, you can see how like the whole thing is like curved in a weird way. It's like curving downwards towards the north and south ends of the facility. And you can see how like it curved so badly that it didn't really reconnect the loop here. So this bowling in particular can be mitigated with just good having good like sort of video path. Does anyone have any questions about like what makes a good versus a bad 3D fragment? Cool. So when you're downloading them, you just don't want to include anything that includes a major defect. You can sort of like run them in larger batches, and that usually reduces the number of defects. You can also, like, if you're recording in lines, what you can try to do is like this. What you can try to do is instead of having the batch be like this, you can like try to like find like up to here and then here and then here and then here. That takes a lot more manual work though, so it's kind of not worth it in my opinion. So that being said, like having a 3D map video is kind of different from a, a good video for a 3D map is not necessarily good video for you to mainly go over. So this is especially true in like partisaning. So like it's probably going to look very confusing if you have a video that's constantly rotating in a and you're trying to like review it to like try to figure out like where things are, but that is actually an optimal sort of thing to have when you're doing 3D reconstruction. Next thing is exporting the fragments. If you're happy with it, you can press this button and click on texture model to download the to export the model. You can also do it from this task page using download assets, textured model, and what you'll get is something like you'll get a bunch of what are called OBJ files and material files and a bunch of PNGs associated with this. You want to sort each fragment in a separate folder because all of these will be named, all of the PNGs will be named the same. So it will like, you'll get a lot of name collisions if you sort them in the same folder. The other issue is that all of these files need to stay in the same place at all times. Otherwise you'll get like missing textures. Does that make sense to everyone? All right. Then what you want to do is you want to clean up the fragments. So I should have downloaded one of these here right now. Let me quickly do that. Actually, I can just open this because it's a zip file and copy it into temp. I like to use MeshLab for this, but you can also use Cloud Compare for this same task. But basically what we're going to be doing is if you look at the 3D model on here, you'll notice the edges aren't like the cleanest. And sometimes you can get like warping downwards on the edges. So what we basically want to do is just cut out the edges. And anything that's like weird in the middle, we also want to cut out. So like So like you can see here that these edges come down on the for no good reason, and we just want to cut those out. So MeshLab is loading. Sorry, my computer is very slow because it has like a bunch of 3D modeling software open. MeshLab, where'd you go? So this is what it looks like in MeshLab. What you just want to do is choose this polyline tool, which sort of works like lasso, and then want to click around the area that you want to keep. Just going to do a rough outline here. You want to press Q to confirm, so that will highlight it in red, and you want to press I to invert. If there are additional areas that you want to delete, like let's say I wanted to delete these crane artifacts here, I can press Q to add that. Oh, that was not what I wanted to do. Let me do that again. So I press D to delete it. You need to press C to clear the polyline also. So let me select the area again. So this is the area that we want to keep. Press I to invert it. I press C to clear a polyline so it doesn't do what it just did. I will highlight the area that we want to delete again and press Q again, and that will add that to the selection. And then if you just press delete, all of the red highlighted areas will go away. So now this is like all nicely cleaned up. You can see that it's tilted. We'll fix that later. One important thing to note is that MeshLab does not have an undo, so you can't Control Z out of this if you mess up. So you just need to start over. So save often. And then once you're done with this, you can export your mesh to hopefully a more permanent folder, which you just want to do export mesh as. And then just save it to a different folder. And it will also automatically save like the it will also save the MTL and PNG files, the texture files. Default options are fine. Okay. Now this is nicely saved for if this finishes saving, this is actually saved for us to do the next step, which is to stitch all the fragments together. So we have a bunch of little tiny pieces of the 3D model. We want to put them all together. To use this, we will use a application called Cloud Compare, which is similar to MeshLab. I just like it because it has a more intuitive UI for stitching. Cloud Compare is currently bugging out, but Oh, I forgot to say that you use left click to rotate, you use middle click to pan, and then you use scroll wheel to zoom in and out in MeshLab. But we are done with this. This is what Cloud Compare looks like. Um, Let me just uncheck all of these so that we can zoom this down into like 2 pieces, and I can show you guys what it looks like to stitch in here. So you can import your cleaned OBJ files into Cloud Compare by clicking I think File Open, and that will import it. I won't be doing it right now because Cloud Compare is hideously slow. But once you're in there, they'll be in like a weird orientation and won't be aligned to each other. So let me just simulate that by doing this. So they will be like this and sort of like weirdly apart. Let me they'll look something like this. I should say it's left click to rotate, right click to pan in Cloud Compare. What you want to do once you get these aligned in or like imported in is you want to align this in a way that allows you to work well with it, like see everything using this tool up here, which is the translate rotate tool. You can left click and drag to rotate something and then right click to pan it. And then what we'll be doing for it is we'll do something called manual hinting, which is basically telling the computer program, hey, this is where these 2 features are, and it will like these 2 features exist in the 3D model here, and they're the same feature, so you should align them properly. So how we'll do that is by clicking this over here, which is alignment. I don't think I chose both of these. I want to choose them in the DB tree first. Oh wait, oh. This is another annoying thing with Cloud Compare is you need to choose the meshes and not the folders that they're in for some reason. You want to align, so one of these is going to stay still. That's the reference. So in this case is 0001. One of these is going to move. That's the to be aligned entity. That's 0051. And what you want to do is you want to like choose 2 points that are the same. So I'm going to choose the edge of this LTS pad. Those are going to be the same point. I'm going to choose, let's say, the tops of this mat vac. I'm going to just choose usually like 5 points. The more points, the better, obviously. One of those points did not register. So let me choose those again. So the top of the mat vac. Joint of this. You don't have to be super precise. We're just giving it a hint as to where it should be aligning things. And let's say like the middle of this small train. You want to make sure that adjust scale is checked off so it can adjust the scale on this. And then click align to shift them together. And it will try to put the points on top of one another. You can see that they're not perfect because I didn't give them perfect points. but the alignment is pretty good. Click the check mark to check it off. It'll give you this transformation matrix, which is what it used to move the to be aligned entity onto the reference entity. You want to do after this is click Find Registration ICP, which is also up here. You want to make sure that the red one is the one that is moving and the yellow one is the one that's not moving. Choose this RMF difference. The default is fine. And you want to make sure that adjust scale is checked off. And it will now align these two sort of more precisely. Does anyone have any questions about this process while it crunches numbers? So this part is the real manual time sync because a lot of the time is just waiting for it to register each other. You guys are still there, right?
Yeah, yeah.
Okay, good.
Mhm.
So one of the issues with this is you can only do this pairwise, so you can only do this to like two fragments at a time. There is a way to do this globally, but it requires a lot of programming, and I am not equipped to do that. So you'll see like global errors accumulate, unfortunately. This is still going, it's almost done though. As soon as this number reaches 0.00001, it should finish. Hopefully it didn't do something crazy. The reason you need to do manual alignment is because, oh, it did something really crazy. Whoops. Sometimes it does that and you just need to repeat the whole process again. Let's do that. Let's do that again. Sorry. Let's actually ignore the fact that it completely failed. And let me just show you the end result. So the end result is going to look something like this. If it will load. Yeah, usually when it goes really slowly, it means that it's trying to do something really crazy. And I think the issue was that I told it that it's going to be 100% overlap when it should be like 40% overlap. I do cover that in the slides, I just forgot that part. Yeah, here. Yeah. Again, Cloud Compare is very slow, and I'm sorry about that. But what you'll get once you merge all of these meshes together is something that looks like, if it'll let me zoom out. Let me stop this also. It'll look something like this basically, where like you get all of the 3D model fragments into one larger 3D model. And you can see it's not perfect, but it's good enough. So if I so you could rotate this around if Cloud Compare was not being such a laggy program. Help with everything. So I could not hear you guys, but welcome back. The step after stitching is to just clean it up. This is basically just going through a bunch of dialog boxes inside of MeshLab, which again does not also have an undo. You just want to click these and basically use the default options. And then remove any of the weird edges. I will not be showing this because it takes kind of a long time and it's just me going through dialog boxes. Okay, and then now comes the fun part, Blender. So once you've opened up Blender, you can click X enter to delete that default cube. And then we want to import in our object. So file import. And let's go find the merged object. Which I do not remember where it is. I think it was this one. That will bring it into Blender. And then you basically just want to orient it in the right way to point it upwards. This was, by the way, the big reason we couldn't use the orthophoto inside of OBS, because it does not know the orientation of it, so it just sort of points it in a random direction. Okay, so now it's brought in here. You can see that it's oriented very poorly. Just want to click numpad 5 to turn on ortho. And then you want to use R to rotate this like this, so it's relatively flat. And here also. You can see that there's this thing that was me stitching weirdly, and then you can use G to translate it. So just ignore this part to the right here. Okay, so that is oriented properly, and then we want to rotate it so that north is up. Something like that. All right. So now that's properly oriented, just going to move it again with G. What we want to do next is to set up our camera and lights. So I'm going to move this over so I can follow it. You guys can also follow along on the website, on the web link, by the way. So what you want to do is you want to change this light into a sun light. You want to put it above the origin and with height 20 meters or something like that. You want to put its rotation to 0, which will point it straight down. You can see that here, it's pointing straight down. Scale XYZ is fine. And then in the light section, you want to set the angle to something like small, like 0.1, and set the strength to like a 2 or a 3. You want to uncheck shadows because we already have those from the in-game footage. Then you want to go into the render tab and uncheck shadows here too. And inside of film, you want to choose transparent. This will give it a transparent background rather than like a black background. Then you want to set up the camera. So in this object tab, you want to set the location to 0, 0, 10. That will put it above the origin again. You want to set the rotation to 0, 0, 0, which will point it straight down. And we can press numpad 0 to enter the camera's view, which looks like this right now. Then want to choose the data and change it from perspective to orthographic. This will mean that it's pointing straight down rather than like a single point perspective sort of thing. You want to change the orthographic scale so it encompasses everything. I think this one was a 14, was like most of this. And then finally, you want to change the output format to encompass everything. So my computer can only process a 2048 by 2048 image, so that will have to do. And now all of the setup is done. And we press F12, and that will open Blender Render. And once it finishes rendering, we will get our ortho image. I know I kind of rushed through that. Does anyone have any questions?
Can you have a project already set up with the camera
Yes.
and lighting?
Yeah.
And you just load it?
Yep.
Good.
The only thing that you probably need to adjust is the you either need to change the scaling of the object or you need to change the orthographic scale to change the size on the camera, like basically the sensor size sort of on the camera.
Mm-hmm.
Blender is working very hard right now. It's just taking its own sweet time. I'm just gonna kill Blender and just show you what that result looks like. What the end result will look like is something like I showed you previously. Ah, ah. Which is this. So we have like every single part of it, and I showed you this in the slides earlier, but yeah. You can then put this in through GIMP to make it look prettier. I didn't do that for what I'm doing with this. And then the last step is to import it into Foxhole Planner. So you can actually import images into Foxhole Planner if you did not notice before. That is not Foxhole Planner. So if you, let me turn on the map really quickly. So if I do file import file import file, and I choose our ortho image here, it will now import, and I can scale it and change its opacity so I can actually see the base map. I can move it, scale it until it fits with the topography in game or on the map. So almost there. It's pretty good. Yeah, it could be shrunk down a bit. So yeah, and then you can use the space map to digitize on top of it. So like, I know like, for example, the mat fac is exactly here. So I can go in and say like, let's put in the materials factory right here. And it basically, if I scale it again, it should line up perfectly. Let me move this to a different layer. Yeah, you definitely need this on a different layer also because images render on top of objects in Foxhole Planner. But yeah. And then you profit. So that is how I made eventually. If I can find it. This plan file. And you can see that it's aligned to the ortho layer on the bottom. Does anyone have any questions on how you use this in Foxhole Planner? Cool. So something that's optional but fun is you can use Blender to render a virtual drone video over it and like just you flying through it. I am not good at Blender, so I will not be showing you how to do this. And also Blender does not like to seem to like me streaming and also recording on OBS. So you can watch someone else's video. These are some potential workflow optimizations. These are very technical, but if you guys have any suggestions on how I could implement these, feel free to reach out to me. These are some more augmentations that will completely change the workflow, basically. Again, if you guys have any ideas on how to implement these or want to implement these, then let me know. Does anyone have any questions about this workflow?
I think I would like to try making one of these, and I probably will have a million questions.
Yeah. Yeah, feel free to reach out to me if you have
Yeah.
any of these questions. Cool. So how you can help with the mapping thing. The first thing is obviously if you want to help, please grab the role in MBG Discord. I think the roles just went up. But you can help with any part of this. You can help take in-game footage of it. You can help host a processing node if you're comfortable with installing WebODM and help process some of these images. You can do some of the manual post-processing and post-process some of these fragments. And this one probably requires the least technical know-how is you can digitize the orthophotos in Foxhole Planner like I just showed. You can also just run another instance of this. You can also just run this whole pipeline on your own also, and I would not be objected to that.
If we were to, like you say, make different fragments,
Yeah,
and then just send the fragments or collect them all into one spot, we
yeah,
could parallelize it pretty well, couldn't we?
yeah. That's sort of like this part of it.
Mhm.
Cool.
Can you mesh together fragments from different videos, or is that hard?
Yes, you can. As long as there isn't like things moving too much, like as long as you're not building too many new things or like vehicles have moved and you don't remove those, you can mesh together different fragments.
Okay.
The other issue would be time of day, but I think a lot of it is based off of the texture itself and or the mesh itself and not texture. So time of day shouldn't be a real issue. Yeah.
So my desktop PC, I have widescreen monitors. Have you played with played with this with a widescreen monitor at all, or no?
No, but it really shouldn't be affected by that.
Yeah, I was just curious if there were any issues you ran into with that. But if you haven't done it, then you wouldn't have. So
Someone asked in a previous one whether like having different different like video or like game graphics qualities would affect it, and I haven't tested that out personally, but I don't think so. I personally play on like pretty crappy qualities, and the result is not great anyways. You can see like in here that the result is kind of like blobby-ish, like you don't get like the full detail of everything.
sure.
So I don't really think that like graphics quality or like screen size would matter that much as long as you're the easiest way would probably be to like let's say you have like two different people recording two different like videos, you do those fragments on your own and then like you do them separate all the way up until this yellow block here, and then you stitch them all together.
And at that
A good
point, you're
question.
sharing images with each other to make this final
You're sharing the
project
3D model
cloud compare.
fragments.
Gotcha. Okay.
Yeah. So like also the good part about this is like with the exception of like maybe like here, each one of these is like a different file. So you can like have one person like take all the in-game footage, send a video file over. Someone extracts all of like the just does like changing the videos into still images, sends that over. Someone does all the open drone map processing, sends over the like the OBJ files, someone does the cleaning. Like there are files in the middle of every single one of these, so you can send files back and forth.
How do they compress one way or another as far as size go? Does it do they get bigger, smaller as you go through one way or another?
Yeah, what scales are we talking?
I would assume they're going to get smaller, right, as you're going through, or no?
That's a
Right, like
great
your video is
question.
going to be the biggest,
Video,
but maybe
this
not. Right?
the open drone map part is pretty big. Like
Okay.
this one, so like the video took 1.5 gigabytes for me. The frame sequence is less, and then the open drone map is like dozens of gigabytes in size. Like I have an
Ooh,
external terabyte hard drive just to store all of this.
yeah, I have a couple.
Yeah. And then it gets smaller. So I think the final the final merge is under it can be under a gigabyte, so it's about the same size as like your video footage.
Okay.
And then the image
Not
file
that small.
itself is only a few
Yeah.
megabytes. So
Yeah.
yeah. All right, any more questions?
Oh, have you done any of these with other people? Have you shared these? Have you noticed any issues with yeah, how do you share your images? Are you or where have you shared them? Have you noticed any issues? You know, my wife and I do not have, she has an iPhone, I have a
Mhm.
Android, so you know, sharing images sometimes you get some shitty images
In
shared,
terms
you
of
know.
like the final image product, or
Yeah. So like if I share one of these at a certain point through, let's say, I don't know, Discord or whatever, is it gonna fuck the whole
it
chain up, the whole
it
pipeline up? Okay.
shouldn't. Yeah, because all of these are like PNGs, so PNGs are pretty,
Oh, okay.
yeah.
Yeah, it's nothing too
The the only
HD.
weird, yeah, is there's no like weird HDR going on. The only weird one that I think might happen is if you have like a weird HDR thing inside like your video footage, but I
Yeah.
think FFmpeg can deal with that. All right, any other questions? Cool. Well, thanks for sitting through my I guess 2.5 hour death by PowerPoint presentation. If you want to do any of this, or if you want further guidance, feel free to like DM me on Discord or inside of the MBG project channel.